4.5, the substitution rule. Problem number 5 says, evaluate the definite integral, the integral from 0 to 3 of the product of 4x and the square root of the quantity of x plus 8 with respect to x. And so we have to start by recognizing that this is a u sub. We have to start by recognizing that this is a u substitution, and so if we let u equal x plus 8, well then du equals dx. And so we can rewrite this integral as a new integral, which is the new limits of integration become, we have to use u equals x plus 8. X started at 0. So the new u limit is u plus 8, or 0 plus 8, which is 8. And then the upper limit would be 11 of, well, now we have a 4x times the square root of x plus 8. We know the square root of x plus 8 is our u sub, so that should be u, and du equals dx, and so we can just replace the dx with a du. But now we have to try to figure out how can we write x in terms of u. And the answer is using this equation up above. If u equals x plus 8, then x has to equal u minus 8. And so let's substitute that. So the integral from 8 to 11 of 4 times the quantity u minus 8 times the square root of u du. Now we have a somewhat easier integral to deal with, and I know that the 4 is a constant, and so I can move the constant out if I would like to, which I am going to do that. And I'm also going to rewrite this the square root of u. So this is the same as u to the 1/2 power. And this is the same as u minus 8. I keep my integral the same from 8 to 11, but on the outside I'm moving the 4. Well, now I would just have to multiply out. I would have 4 times the integral of from 8 to 11 of u to the 3/2 power with respect to u minus 4 times 8, which is 32, times the integral of from 8 to 11 of u to the 1/2 du. And so using the power rule for integration, we add 1 to the power and then divide by that in both of these scenarios, and we would get an antiderivative of 4 times the quantity u becomes u to the 3/2 becomes u to the 5/2, and we divide by 5/2, so that this is like 2/5 out front. But we're also evaluating from 8 to 11, and we're subtracting 32 times the quantity u to the 1/2. We add 1 to the power, so that becomes u to the 3/2 power, and then we divide by that power, so we have 2/3 u to the 3/2 evaluated from 8 to 11. And so our next step would be to plug in. So we have 4 times the quantity 2/5 11 to the 5/2 minus 2/5 8 to the 5/2 and then that is subtracted by 32 times 2/3 of 11 to the 3/2 minus 2/3 8 to the 3/2 power. In order for me to find the answer of the problem, I'll use the calculator to help. And so what I'm going to do is I'm going to do 8/5 or 8 divided by 5 and click enter. That's going to give me that number. And now I'm going to times that by an open quantity brackets, and inside those brackets I'm going to insert some stuff. So 11 to the power of, and I'll put parentheses, 5 divided by 2, and then I'm going to subtract 8 to the power of 5 divided by 2. And what this quantity is giving me is this value. So just note that all I did was factor out a 2/5. And so when I did that, this became our 8/5. And so I multiplied that number by what was left, which would just be this 11 to the 5/2 minus 8 to the 5/2. I'm going to do the same thing over here. But let me find this answer first. I would get 352.4676218 minus, and then for the next value we have, I'm going to do a similar scenario. I'll do 32 times 2. I'll do 32 times 2 and then divide by 3. And this is our answer. And then now I take this number, I take my answer, and I'm going to multiply by the quantity 11 to the power of 3/2 minus 8 to the power of 3/2. And I'm given 295.5830548. And now I just have to subtract. So this number subtracted by the last number equals 56.884567. And so this would be our final answer.